Okay, we are here in MABRU Power System introducing our new 17. It's really an 18. We are going to call it 17. This unit in particular is a variable speed compressor. Mini splits call it the inverter technology. It's not really an inverter technology, it's more like a frequency drive principle that you can slow down the speed of a motor based on the need. This is connected to a pump in our tower and is increasing the speed of the pump. The same way is working with this compressor. It's working on 3-phase AC, but it's taking 110 volt and it's converting it to 3-phase. This unit got a very beefy evaporator. It's the same size of a 16, 13 inches in height, 3/8 pipes. All the coil, it's copper, so it's copper tubing and copper. The technology that is on that, it's a frequency drive. Same as that frequency drive that you see on that, it's inside this box to control the speed of the compressor. It's not an inverter, it's a frequency drive. So this unit at this time, we have a set point of 84. It's very close to the temperature of this room. So this unit is able to run at 4.4 amps continuously, consuming 4.4 amps, and it's giving me a 12 degrees differential on a medium speed that you can see. This is not just a little bit of air. This is a hurricane. 350 CFM on 12 degree differential, saturated the coil, an amazing thing. No starting amps. This unit will not peak. It will take few seconds for the unit to get to speed, but will not have any starting amps to get there. There is no vibration. The unit is running right now. We are going to see with the camera on top of the compressor to see the sound of the compressor. You can reach in. You are going to see. You can feel it. Only you hear is the fan, and you see the sweat. This is full saturation. There is a reversing valve, so this is a heat and cool unit. The fan is a very smart fan, 110, but permanently magnet motor, very low amperage. The case is complete. It's an L-shaped drain pan, the way that you can rotate and blow down in certain application or blow up. This is very easy to rotate. 3/16 stainless steel, I repeat. The ring is 6 inch and it comes with the unit. Here you can see you have a magnificent air velocity, and it's not at full. At full speed, going to 18,000 BTUs to cool the boat really fast, I'm going to lower the temperature. Set point right now is 82. The cabin is at 85. The fan suddenly is going to increase the speed. Now we are at 5. Compressor goes faster, 5.7. And now the fan is going to another speed, and now it's even worse. Extremely quiet, a lot of static pressure. Like that, I can have multiple vents. The unit will never freeze up because Instead of having a capillary, there is an electronic expansion valve that is monitoring the temperature of this coil, and when the coil gets to be too cold, too much restriction, this unit is monitoring the refrigerant flow and is monitoring the speed of the compressor at the same time, and is also monitoring the speed of the fan. So everything is working with this microcomputer. The control. Okay, there is a remote control for the sensor to have a more accurate reading. Sometimes vents are blowing toward the control, so we want a remote sensor in temperature. Our control is touch screen. The bezel is included. It's very easy to operate. It's temperature down. Now I'm at full speed at this time. The unit is presenting 13 to 15 differential. Even more. I can you can see the air velocity is even more. I'm making a beast out of this unit. Compressor goes up. I'm cooling a whole 40-footer with half cabin just with this unit. We were doing a demonstration on a 40 Regal half cabin, normally they have 2 units, 16,000 BTUs domestic. We were able to put this unit in the salon, and it was cooling the whole boat much better than he ever did before. We are going to talk about the pressure, the static pressure. 600, even more CFMs out of this blower at high speed. And we're talking about the velocity. You don't hear it, but you can feel it. This is what we're talking about. This is, several feet away. You imagine in a salon vent how nice it is to have all that. Look at how far we are. We are like 7 feet. And look at the velocity that we have out of that. All the way. Talking about quality. Our units are made with a CNC. Everything is computerized, even the welding. So there is no overheating on the welds. Everything is precise and every weld is the same. All the pipes are bent by CNC. Not only this unit, you can see our 7,000, this is a 7,000 BTUs, 110 volt. Everything is precise. The coil, talking about the condensing coil, we are the only one now presenting military quality copper nickel 70-30, not the 90-10 that most of our competition got. This is very important because this is a 20-year span condenser compared to a 2 years to 3 years condenser. All that little differences. This fan, it's a ball bearing fan, not a stainless steel ball bearing. The reason is because there is a lot of humidity, and when you shut down the unit, the ball bearings are presenting humidity and moisture inside, so some corrosion is always happening, and eventually throughout the year the bearing get damaged. So that's the sound that you get out of the fence, the wah, 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 wah. So you don't have that. Plus the permanently magnet is creating a lot of torque on the side, so ceramic has less friction and less consumption. Right now at full speed, doing about 18,000 BTU through the lab, we are at 8.1 compared to in 110 volts. We are running this thing with to make it crazy. We are running this thing with a 16 gauge wire, and it's not even hot. Just to show that we can start this unit with a 16 gauge wire. It's not recommended. We want the customers to use at least 14, possibly 12, just for having a better setup. We really want a 16,000 BTUs to run on a 12, but just to push the envelope, we were able to start this unit with a 16 gauge wire. That's nobody, there is no competition that is going to be able to do that. Something very important, we are reaching set point temperature. It's 86, the unit is set up at 83. I'm going to put it close to set point temperature. The unit is going to recognize that it's getting close to that set point and it's going to slow down. So from 8 is going down already 7.8, and it's going to still going out even more. Right now it's 7.8. It's going to see that the temperature is still so we are slowing down the unit just to keep the boat comfortable, but without cycling on and off. Now it's 7, 6.9, very comfortably. So 6, and it's going to go down on the 4. Just to tell you how wonderful it is to have a unit that got a 13 degrees differential on a 4.5 amps on 115, 4.4, 4.3, compressor still running. We're still having at least 300 CFMs to blow, and you're running on batteries through an inverter that is producing from 12 volt or from 24 volt, is producing power to run this unit. A normal unit is running on about 10 amps. So if you're running through an inverter, you are at 110 amps on 12 volts. If you have 4.2 and if you're running on inverter, you are in 40, 44, and you're still having a 12, 13,000 BTUs. But when you want to cool really fast the boat, so you can increase the speed, you can cool it on 18,000 BTUs, and then to maintain it and to save your batteries, you can slow down your unit. That's the advantage. First of all, at high speed, we are running at 8, maximum 9. Most of our competition to do 18,000 BTUs, they are in 13, 15, 16. We are not only in half of the amperage, but we can slow it down to 4 point something, and then if you are running on 12 volt, you have to multiply by 10 times. So if it's 10 amps, it's 100 amps, plus the loss of the inverter. Higher is the number, more losses you have. So when you're running at 4.3 or 4.4, it makes a big difference. It's a really big advantage to be able to run on a battery. Having this battery in particular is able to run this unit to maintain the temperature in about 6.5 hours. So if you have 2, you have 12 hours. If you have solar panels, even better. So that's practically one of the first units. I'm not saying that we are the only one with the inverter technology, but we are the only one that we're able to master doing an installation that is easy. When you remove this blower, you have a chassis that is so narrow that will fit anywhere. Same thing with this unit. You know, you remove this blower that is only taking this thing loose and taking the blower. You have a unit that fits in any hole, and then you put the blower inside. The box You connect your wires and then you connect your box. You put the box on the boat. Everything is remote. The cable is included. The bezel is included, and it's touchscreen. If you want to know what happened with the unit, you will go with alarm, and you will see in here all the list: high pressure, low water, dirty filter, any kind of thing. You will see it here on the list. You come back. You want to see what is going on with the unit. Let's say you want to see that. They say, oh, now the compressor is off, the pump just got on, the heat is off, the valve is off, the return temperature is 86, and the evaporator is 78 because the compressor just shut down. I go back. Now, the compressor already started. 6.5, look at it here. I'm going on the menu. Now it's telling you compressor is on, the pump is on, the heat is off, the valve is off, return temperature is 86, the evaporator temperature is already at 70. We have more than 16 degrees differential. So when you're calculating on a 480 at full speed, 550, 480 CFMs with a 15 degrees or 16 degrees differential, you can cool the boat extremely fast and you can drive the boat very fast. That's what it's all about. You want to be comfortable on your boat. So here it is. This is the best system, the best unit in the market. And this is why I would like to emphasize that this unit is the best one in the market for all those reasons. The reason that the blower is the best. The blower is the one that got the most static pressure and less noise to be able to go to the vent. Got ceramic bearings. Got the best motor. The condenser, it's a military grade, 70-30, not the 90-10 that most of them go. The compressor is a variable speed compressor, 3-phase, working on a 110 unit. The valve is not a thermostatic expansion valve, it's an electronic expansion valve. The computer is monitoring, not only the compressor, is monitoring the compressor, the valve, and the fans to work in harmony. They have to work together to produce the BTUs. That's why we were able to achieve 4.4 or 4.5 amps and still producing close to 13,000 BTUs and 110. And 8 amps, 8.5 producing over 18,000 BTUs. Nobody even come close to that. Thank you very much. We are here in Dania, Florida, and you're welcome to visit our installations. Thank you.
Thank you, Mr. MABRU. And I invite you to come to MABRU Power Systems in Dania.